Can you tell me what is ZPF? What do you mean by ZPF? When power factor will be 0? In which case? In which case, whether it is resistive load, inductive load, capacitive load, maybe leading or lagging case, but it should be pure. See, this is suppose voltage. If current is lagging voltage by 90 degree, and this cos of 90 is equal to how much? 0. Or in another case, suppose this is voltage and current is leading to this voltage by 90 degree, then this cos of 90 will be 0. Okay, so 0 power factor when it will be in case of leading or purely inductive or purely capacitive. So if it is purely capacitive, then it is leading power factor. Okay, leading ZPF. This is lagging ZPF. Getting or not? Yes or no?
Yes, sir.
Okay.
Yes, sir.
So in case of alternator, the armature resistance drop, that is nothing but IRA, and leakage reactance drop. What is leakage reactance drop? IA XL. So these two are EMF quantity. These are the EMF quantity, right? But armature reaction is a MMF quantity. Okay, so in this case, this method, it is based on the separation of armature reaction effect and armature leakage reactance effect. So what is the procedure? Let us see the procedure for ZPF method or Fourier triangle method. Procedure, you may note it down. First step, we have to plot the same way. The data required for this method is we require open circuit test, short circuit test characteristic, and armature resistance. As it is a indirect method, for indirect method we require OCC and SCC. So what we will do, we'll just plot. This is VOC, this is ISC, and this one is IF. The first step, I have to plot the OCC and SCC. Sorry, only OCC we require. So I will plot this OCC, open circuit test characteristic. Okay, once it is plotted, we have to plot a current. Let us suppose this point is O. We have to plot the current, that is a rated current. We may say that it is the excitation current required to produce the zero terminal voltage, and that is nothing but the short circuit zero power factor full load current. So once we know the that current, I will plot that current. Means suppose that current is 10 ampere or 20 ampere, and in this case I have considered that 10 ampere is equal to 1 centimeter, right? So for 20 ampere I have to consider 2 centimeter line. So with appropriate scale, we have to plot that current. Let us suppose this is current, and I will plot or name it as A point. Lakshay Dega, I have to find out that current which produces the zero terminal voltage. Okay. And for example, I will consider that that current is 20 ampere, which produces zero terminal voltage. Okay. So by taking appropriate scale, I have to plot that point and I will name it as a point A. Again, we have to draw a tangent to this open circuit test characteristic, and that is nothing but the air gap line. This is air gap line. Okay. Once OCC is plotted, next step we have to draw a tangent to this OCC, which is nothing but the air gap line. After that, we have to plot the current which is responsible to for zero terminal voltage or short circuit zero power factor full load current. Okay, so that point is named as point A. Next step, again we have to mark a point P, which is indicating rated terminal voltage at full load, zero power factor lagging. So let us say suppose at particular current of IF, we are getting rated terminal voltage of, आता या केसमध्ये सपोज 230 rated voltage आहे. So for the value of IF, let us say suppose this is the value of IF, at which at this point I am getting the rated terminal voltage here. So this is point P. Okay. Again from point A. Okay, from point A, according to this OCC, I will just move this point toward this. We have to draw the saturation curve, which is passing through point P, which is just like OCC. So once we got the point P, we have to draw a parallel line to this x-axis, but the length of that line, it should be equal to OA. Okay, so what I will do, from point P, I will draw a parallel line to this line OA, but the length of that line, it should be equal to OA. So let us say suppose this one. Once this line is marked, which is having length equal to this OA, we will name it as point Q. Okay. After that, just draw a parallel line to this air gap line from this point. Okay. So I will just draw a parallel line which is equal to which is parallel to this air gap line from point Q, which will intersect at point let us suppose R on OCC, and after that just join this point RP. Okay, so this triangle PQR is nothing but the Portier triangle. So this is nothing but the Portier triangle. Okay, and after that we have to just draw one perpendicular line from point R on this, so that you will get a point. Let me check once. Yes. Okay. So this is the procedure to plot a Portier triangle, and how to solve the numerical by using Portier triangle. First step, we have to plot open circuit test characteristic. Okay. So how to plot that? What is the significance of this Portier triangle that we will see in next lecture? Just remember this. This is IF. This is POC. So what we will do, I will just plot this open circuit test characteristic from this open circuit characteristic test data. Again, once it is plotted, I will name it as point O. Next step, we have to draw a air gap line which is parallel or tangent to this OCC. So I will just draw a tangent line which is air gap line. Once it is plotted, the next step, we have to plot excitation current which is required to produce zero terminal voltage on short circuit. Okay, so let us suppose there is a value of some IF at which we are getting zero terminal voltage on short circuit, zero power factor load current. So with appropriate scale, I will just plot this OA, which is just indicating excitation current. Once this point A is marked, we have to plot or mark point P, which showing the rated terminal voltage at full load, zero power factor lagging. So let us suppose this is point P, at which we are getting rated terminal voltage on full load, zero power factor lagging, and just as per this line, we have to just draw this curve which is passing through point P. Once point P is plotted, we have to draw a parallel line to this x-axis, which is having a length equal to this OA. So from point P, I will draw this point parallel line which is having length equal to OA, and this point is Q. After that, just draw a parallel line to air gap line from point Q, which will intersect to open circuit test characteristic, and this point is R. and after that joined RP, and the next step is just draw a perpendicular bisector from point R, which will give you point S. So once this is plotted, this triangle is nothing but the portrait triangle